Hello everyone. So in this video I will walk you through k-means clustering algorithm. So k-means clustering algorithm is a popular unsupervised machine learning technique used to partition a given dataset into k distinct clusters. The objective of this algorithm is to minimize the sum of distances between the data points and their respective centroids within each cluster. The algorithm starts by randomly assigning k centroids to the data points and then iteratively updates the centroids until the convergence criteria are met. So step 1 starts with initialization. The algorithm randomly selects k data points from the dataset to serve as the initial centroids. These centroids can be chosen randomly or based on some prior knowledge about the data. So this is the initialization step. So we have all these data points and it will start by randomly putting, so if you want two clusters it will put two random points which is called a centroid, and if you want three it will put three, four. So depending on how many number of clusters you want, it will start with two or whatever number of clusters. K is the number of clusters that you want in the k means. So this is the initialization step, and next is each data point is then assigned to the cluster with the closest centroid based on the Euclidean distance between the data point and the centroid. This distance is calculated as the square root of the sum of the squared differences between each feature of the data point and the corresponding feature of the centroid. So this is how. So this is like in the previous diagram. So all these data points, the distance will be measured. For example, this data point, it will check whether it is closer to blue or to the green. So it is closer to the blue, so it goes into blue cluster, and this one is checked whether it is closer to green or blue, but since it's near to green one, it will go to the green cluster. So that's how all these data points come to this green cluster, and this will come to the blue cluster. And this is how the assignment. So this is the assignment stage. So now the first iteration has been done, and third is step 3 is update. The centroid or centroids of each clusters are then updated by taking the mean of all the data points as data points assigned to that cluster. This new centroid is the geometric center of all the data points in that cluster. So we'll see that I will explain all this visually in the next few slides, all this update and all, because this is very involved. So this is next is repeat. Then we'll just repeat step 2 and 3, basically assignment and placing of the centroid. So step 2 and 3 are repeated until the centroids no longer change or the maximum number of iterations is reached. The convergence criteria depend on the implementation and can vary based on the problem. And final is the step 5, which is the output, which is the last step. So the outputs of the k-means algorithm is the final set of centroids and the assignment of each data point to its corresponding cluster. So before we try to understand the algorithm, we'll just cover two basic definition: what is a centroid and how to calculate the distance on a graph. So first we'll start with centroid for a one dimensional line. So if you have a line, you just can see like this is a one dimensional line, so you can ignore the y-axis because it's on the x-axis. So y is anyway 0 for both the points, so you can just figure out between 1 and 3 the center point is 2, but mathematically it is like x1 plus x2 by 2 and y1 plus y2 by 2 because it's a two data because it's a line, the 2 points, so we divide it by 2 and then we just do the maths and it will come to 2.0, which will fall over here. So x-axis is 2 and y is 0. So and same two-dimensional line which is on a graph, so it has got x and y axis both components. So if we use the same formula, put the numbers, so 2 plus 4 x 2 plus 4 and 1 plus 3, so 1 plus 3 and 6 by 2 4 by 2, and it will come centroid will be 3.2. So this will be 3, 2, sorry. So it will be somewhere over here, And same now after a line, let's see how to do for a triangle. So I have got a triangle over here on a graph, and A, B, C, these are the points. So if you want to know the centroids, same thing, x1, x2, x3 by 3, and y1, y2, y3 by 3, and you just put the numbers 2, 4, 4, and 1, 1, 3. So y is 1, 1, 3, and divide by 3. Just do the maths. It's coming dot 3.3, comma 1.7. So centroid will fall somewhere over at this particular point. Now we'll just do the last one for the rectangle or any shape which has 4 points. So I have got a sample rectangle and with their coordinates, and now we'll just so same thing, you have to divide by 4 in this case. So x, you just take all the x components, y components, divide by 4. So just put the numbers 2, 4, 4, 2, 1, 1, 3, 3, 5, 4, and divide, and 3.2. So even without putting the dot, if you just visually look at this particular rectangle, you know the centroid will be exactly somewhere over here, halfway from length, halfway from breadth, somewhere over here. So even if mathematically it is 3.2, so 3 and 2, it comes over here. So last is distance formula. So this is from your mathematics, high school mathematics or school mathematics. This is Pythagoras. So what is the length of C? So we just do a square, b square, and square root. So if it is a and b is 3 and 4, 3 square plus 4 square, 9 plus 16, and the square root of 25. So C will be 5. So this is if you are just based on the lengths. But what if it's on the graph? So on the graph, we just have to do like x2 minus x1 square, y2 minus y1 square. So I am trying to calculate the distance of this particular line. So point A is 2, 1 and 4, 3. I want to calculate how much is the distance, the length of D. So I'll put the numbers 4 minus 2, 4 minus 2 square, 3 minus 1 square, and square root. So 2 square, 2 plus 2 square, and 4 plus 4 square root of 8, 2.8. So this length is 2.8. So now we know the centroid and distance formula. Now we'll go to the actual algorithm. So I start with all these data points. I have labeled them as red. So just consider red as a neutral position or the start position. So they don't belong to any cluster. Now I want 2 cluster to start with. So it can be K, can be 2, 3, 4. This I'll come, but just to make it simpler and easier to understand, we'll start with 2. So when we start with 2, the algorithm will just randomly put 2 data points, and it will calculate the distance. It will calculate the distance every point to both the data points. So blue and green. So for example, this point, you will see what is the distance between itself and the blue and the green, and then same other points, it will calculate what is the distance, and if so whichever is nearer. So for example, this is nearer, this blue is nearer, all this, of course blue is nearer to them, and for all this green is nearer, so they will go to the that particular colored cluster. So all this will go to blue, and all this will go to green based on the Euclidean distance. If you want to visualize, you can just use simple technique. You can just use this simple technique. Just connect these 2 points, straight line, and exactly midpoint. Just create a perpendicular 90-degree line, and automatically this point will go to the whichever falls on the right side will go to the green, and all the points to the left will go to the blue cluster. It's very obvious. For example, if I put a point here, somewhere over here, it will be nearer to green, but it will be bit 0.1 centimeter or something will be further away from blue. So anything over here, this part will become green automatically, and this part will become blue automatically. So this will go to the green cluster, and to the left blue cluster, and this is we have the initial cluster. This is just the initial cluster. Now the centroids, these 2 are the centroids. They will move their position. So at this point, for this data points, the centroid was calculated, and then the initial centroid went to the next centroid. So centroid has moved and then we will repeat the algorithm again. So same thing, all data points are now back to the red, which is the neutral position. Now they don't belong to any cluster, and we will calculate the distance based on the Euclidean, but to make you easier to understand, I just draw a straight line, and exactly at the midpoint I draw a perpendicular 90-degree line, and right side automatically this will become green and this will become blue. So you will see these two data points, this and this, were earlier in the blue cluster, but now they have changed from blue to green. And since now the second cluster was formed, then same a new centroid was calculated based on this, not this one, and it moved slightly here, and this thing, second centroid moved here, third, based on the other data points. Now it will just repeat, and then it will calculate the Euclidean distance between all the points. That's why they have all the data points are back to their neutral position. And finally this centroid will move, and this time the cluster assignment hasn't changed, the data point hasn't changed, and centroid will also stop moving after some time, and those will be the final clusters. So this is how we have divided the data points into two clusters, and this can be taken. So what if we want k equal to 3? So for k equal to 3, it may look something like this: blue, red, green. And what if we have k equal to 4? It may look something like this, with pink and green, pink cluster being added. And you can go to extreme, and I can ask for k equal to 16. So every data point, we have 16 data points, so every data point is having its own cluster. And now the question is how to know what is the optimal number of clusters. It can be like 2. Of course, it cannot be 1 or 16, the maximum. It will be somewhere between more than 1 and less than maximum. So there is a formula like sum of squared error. So I'll just showcase for 4 because it's easier. If it's 2 or it's a very high number, it's very difficult to explain. So let's say I have 4 clusters: blue, red, pink, and green. So these are the data points, and for the data points I have just put a centroid. For the blue, this is the centroid. For the red, this is the centroid. For the pink, this is the centroid, and green, this particular is the centroid. And then we will calculate the squared distance. So for this one, so we just take for this, I calculate the distance and square it, calculate the distance, square it, calculate the distance, square it, and square it. And this is sum of squared error for this cluster. And then for this cluster red, and same, this is for the pink, and this is for the green. So for 4 clusters there will be 4 sum of squared error. So if it is 2, it will be 2 sum of squared error. For 10, it will be 10. So finally I have got for 4 clusters this particular value, and then I add it up, all up, and this will give me a final total sum of squared error for 4. So same way we will have for 2, 3, 4, 5, 6, 7, 8, all the way up to maximum number of data points, and then we plot it on a graph. So sum of squared error for the one cluster. So if it is just all data points are in just one group, so the sum of square error will be maximum, because all the data points, you can imagine, they have to travel very long distances to reach to the centroid. So that's why this number will be very high. And the extreme case, if it is 16 clusters, so this is the number of clusters. So it starts from 1 all the way to maximum number of data points. So if it is 16, the data points are in their own cluster, so there is no distance traveled. So everything will be 0, 0, 0, 0. So final value will, if you add up all the zeros, it will still be 0. So when you come down like this, this reduction will happen, sum of squared error from 1 to 2, 2 to 3, and 4. So this will be drastic at the beginning, but once it goes down, it will go down a lot. So at this point, wherever this elbow joint is there, we say that is the optimal number of clusters. So it will be somewhere over here. And some important considerations. The algorithm is sensitive to the initial placement of the centroids, so it is often run multiple times with different initializations to ensure that the results are not biased by the initial centroid placement. Additionally, the choice of k, the number of clusters, is often subjective and can impact performance of the algorithm. Finally, k means clustering assumes that the clusters are spherical and equally sized, which may not be the case in all datasets. And that's all. Thanks for watching.